Okay, I'm back in the app, and you'll notice now I've got a few more tasks, and they are slightly different. If you're wondering how I did this, given that we don't yet have a delete task function, the way I did that was by uninstalling the app and reinstalling it. Later on, we will need to allow users to delete tasks rather than just mark them complete. So feel free to uninstall the app on the phone and then reinstall it to add some new tasks if you would like. But I've gone ahead and added 4 new tasks. Take out the bin, mow the lawn, record a new Android course video, sorting tasks, and edit course video, sorting tasks, which is this video we are doing right now. Because if I were to mark one of these complete, say for example mow the lawn, well, we strike through the text to show that it's completed, but it stays where it is. And typically in to-do lists or task lists, whenever you complete a task, it does move to the bottom, so you have all of your incomplete work on top, as that's probably what you're most interested in, the things that are still to do. So this tutorial, we're going to find a very simple way to sort our data so that the completed tasks, when they're marked complete, will move to the bottom. I'll just uncheck that for now. Our recycle view updating nicely, and I'll head to our tasks adapter. Now, we're going to perform the sorting of the tasks here in the adapter. It is worth saying you could also sort it from the database, but as we've been working with our tasks adapter, it's absolutely fine for us to sort the tasks here. So, fortunately for us, because we have a list of tasks, well, in Kotlin, there are some really useful functions you can call on any list that will do things like sorting them, or comparing them, or filtering them, okay? So if I make some line breaks above where we set the tasks, in our set tasks function, I can show you some of these. So we have tasks.sort, and you can see we have sorted by, and then some curly brackets, as well as sorted by descending, with some curly brackets. Those two functions do a very similar thing. One's in ascending order, one's in descending order. And we want to sort our tasks by whether or not they are complete. So if I do sorted by and autocomplete, and then a line break, you can see we have a space now to give some condition for how to sort our task. And what we can do here is give some part of the task, whether the name or the complete status or something else, basically anything that can be compared, we give the criteria here. So for example, if we wanted our tasks to be in alphabetical order, and a new syntax for the way that we do this. If you look closely at the top of our curly brackets, you can see it says it:task. So within this scope, meaning within these curly brackets, we actually have access to the individual task. We have our list of tasks, and sorted by will go through each and every task one by one, and we'll look at the task and see what the value is, and put that in order. So we can go ahead now and do it, which refers to our task. You can see there autocomplete shows it is a task, so it dot, and then we can choose any of the properties. For example, if we wanted to sort these by alphabetical order of the title, we could do it.title. And then the error goes away, because this can be compared. When you have some string, some text, or some characters, it can inspect that, and it knows how to sort words. It will sort it in alphabetical order. So let's do exactly this. We'll make a new property which represents our sorted tasks. Okay, so sorted tasks equals tasks sorted by it.title. And then this.tasks equals sorted tasks. And when we go ahead and run this now, and we look at the title, E-M-R-T. The title is now in alphabetical order. Cool, right? And if we wanted that in reverse order, we would simply do sorted by descending. And when we run this, it goes the other way, T-R-M-E. We could do the same for the task.description. And we can do alphabetical order again, so sorted by. And run this. And now we need to look at the second line, the smaller text for the description, B-R-S-S. So this sorted by function is super useful. Anything that can be compared, and you can compare text, alphabetical order, you can compare numbers, numerical order, and you can also compare true or false, Boolean, which will help us in a moment for our completed task status. In Kotlin, with lists, it knows how to sort those values. So let's do exactly this now, and rather than sorting by alphabetical order for our title or description, let's instead sort by our isComplete status. And if you think back to SQL, false represents 0, and true represents 1, so doing sorted by should give us our false things first and our true things second. So let's see if we run this now, if this achieves what we want. Okay, so our tasks aren't in any sort of alphabetical order. They're in just the order that I added them to the database. But if I choose, say, mow the lawn and change this to be complete, mow the lawn moves to the bottom. Fantastic. False is 0, so all the zeros are on top, and true is 1 in the programming world, so the true values go on the bottom. I can then record my video as I'm doing now, and that moves to the bottom. I can unselect that, and it goes back to where it was. Fantastic. So sorting tasks when you have lists of things in Kotlin is super easy. We don't actually need to make a new variable called sorted tasks. We could delete this, and we could go ahead, change this back to tasks, and do tasks.sorted by it.isComplete, all in one line, and remove the line breaks. And when I run this, we get the same effect. The completed items are on the bottom, and when we uncheck them, they go back to the normal order. So that's pretty much where we can leave it for a very easy way to sort our tasks, to put the complete ones on the bottom, to give a better user experience. However, looking at our sorted by function, if I put it as a block again rather than inline and do this, and we see this it task thing here. Now this is something new. Each of our individual tasks being referred to as it. And actually, we have the ability, if we want, to not have it be called it, but have it be called anything we want. We could call it just one task, singular, and then do the arrow, and then now, we don't refer to the task as it, we refer to it as task. We could call it anything we want. We could call it, you guessed it, cheese, okay? And then cheese.isComplete. So in this strange scope syntax where we get given an individual task like this, well, if you don't name it, it gets called it by default, but you have the ability to name it inside this scope. And I keep saying the word scope because this leads beautifully into the final concept of this section before we move on to the next section. And that was something we mentioned in the section overview on Kotlin scope functions. This thing where you're given an individual item and it is called it. This is something new. We've seen things like this before, but I don't think yet we've seen the word it. And Kotlin is a very clever language, a bit more sophisticated and advanced than Java, in my opinion. So now we're going to do a few short tutorials on the idea of Kotlin scope functions, where you can make code blocks like this, and then you're able to do interesting things like have your variable referred to as it, or the ability to name it as anything you want, as well as doing some cool things with null safety. And knowing these scope functions will make this syntax make a bit more sense to you. So I'm not just showing you something new and saying deal with it, but actually you'll kind of understand what's going on and how this it syntax is quite common in Kotlin. But not only that, if we go down to a bind function, where we're doing binding dot, binding dot, binding dot over and over and over again, well, after I teach you a couple of these new Kotlin scope functions, we're going to be able to clean up this code a lot and prevent a lot of repetition. And that'll be a really nice way for us to finish this first section on databases by learning another super cool feature of Kotlin and then using it to improve the quality of our code. So let's head over to some new Kotlin Foundations tutorials before coming back. Time now for another Kotlin Foundations tutorial, this time on scope functions. I'm here in the official documentation, similar to the Android documentation, but this is purely focusing on Kotlin. You can get to the same page with a quick Google search simply by typing in Kotlin scope functions and getting to this page. And this page gives us a good overview of what scope functions are. The Kotlin standard library contains several functions whose sole purpose is to execute a block of code within the context of an object. Now, this overview page talks about things like code blocks, object context, Lambda expressions, and I find for beginners the way they describe this isn't necessarily the clearest. However, the examples they provide are helpful. In simple terms, they're talking about the Kotlin library containing some functions, and their purpose is to execute a block of code within the context of an object. And if we jump down to this first example, it makes things a bit clearer. So they're talking about these curly brackets being a block of code, a scope. Now, where have we seen the word scope before? Way back when we first learned about variables, back in the Java section. We talk about local variables, maybe a variable that's declared in a method or function, and that local variable is only available in that function or method scope, between that function's curly brackets. It's a very similar kind of thing. We're creating these mini scopes in these blocks of code. And they talk about it being executed within the context of an object. We'll see here we have this person object, and then we call .let, one of our scope functions we have available to us, and then these curly brackets, which is the lambda. We've seen this once or twice before. So we have this code block, this scope, and within the context of this scope, we have access to this person. And then in their second paragraph, they say that basically all of the various scope functions perform the same action, and that is executing a block of code on some kind of object. Simple as that. So what's the big deal? Well, in this case, we have a person object, we call .let, and we have this code block, and within here we can refer to person as it, print it.move to London, it.increment age, okay? However, in their second example, they say that if you write the same without this, well, maybe your code would be a bit more clunky and cumbersome. You'd have to introduce a new variable called Alice, so val Alice equals, and then your person, and then perform lots and lots of operations on the variable, print Alice, Alice.move to, Alice.increment age, and so on. And their final point they mention, these scope functions, they don't introduce any new technical capabilities. These are all things you can kind of do in different ways. Like this second example here, it achieves the same thing, but they can make your code more concise and more readable. And that's the whole point. These are things you can't do in Java, these scope functions. And hopefully you're going to see in the next few tutorials, and when we start to apply it to our projects, how indeed it does make our code more concise, more readable, a bit more simple. I'm going to scroll down to a little table they have on this page. It shows you the various functions they have. It's basically 5 types of function: let, run, with, apply, and also. And just so we don't end up going into too much detail right at the end of our database section, I'm going to pick out by far the most useful and the most commonly used of these. And in my experience in Android, these are the let scope function, and then down there, the apply scope function. But all of these functions do the same thing. You call the function on any object, on any variable, and then you get this block of code, this scope, where you can write some more code, and you will have access to the object in one way or the other. Okay, let's dive now into a little workshop, and we'll start with the first of these, the one that we've seen in the examples above, which is the let scope function. So let's do that next. I'm in Android Studio and I've made a new Kotlin Scratch file called scope functions, and I've put it inside my Kotlin Foundations folder. If you can go ahead and do the same. And now I'm going to close the project pane, and we'll just be working in this file for the next couple of tutorials. A file called scope functions, we'll put them all in here as we add to them, and in this first workshop we're going to focus on the .let scope function. You can see here after the heading of .let and then the curly brackets, the code block, the scope. Feel free to do your heading however you want for your own notes, okay? All of these scope functions allow us to call one of the functions, like .let, .apply, .also, on an object, on a variable, and then we have access to that object or variable in this new scope. Before we start making notes on this, the most useful thing to do will be just to show an example of this. So we'll go ahead and we'll make a new data class. And just so we can relate it to our course, we'll make it the class of type task, as if we're doing our getItDone app, okay? I'll do a line break and put the class constructor properties on separate lines. So the ID can be an int, that can default to 0, why not? We'll do a title of type string, which must not be null. We'll do a description, which could be null. You don't have to have a description. We can default that to null. And then we'll do is complete. This can be a Boolean. It can default to false, okay? So not too different from what we have in our getItDone app for this section. And say in your code you had a potentially nullable task. We could have a var, my nullable task, of type nullable task, and that could default to null initially. And then maybe later on in your code you would create the task. So my task equals task. We only need to give it the title. We'll use named arguments, good practice. My task that now exists, okay? My nullable task, null, task could, null. They change everything about it. So then you'd have to write code that looks a bit like this. My nullable task dot, we'll make it so that, and if I duplicate that 3 more times, we'll do this complete can be now true. My nullable task got changed to null again, like this. But it's a bit clunky to type. Well, that's fine. All of those lines, 21 to 24, nothing would happen. It would just resolve to null. So that's perfectly safe, but it's a bit clunky to type. So one of the main purposes of the let function, and one way where it's commonly used, is to check whether the variable is null or not. And then if it's not null, call .let, and then within the scope you have a guaranteed non-null value. If that sounds confusing, let me show you exactly what I mean. So now we'll do my nullable task, we'll do a question mark, and then .let. And then you can see we have this little grey text that says it, and it is of type non-null task. If I remove the question mark, well, you see the question mark appears there. So you can call .let on any object, any variable. If it's nullable and you don't put a question mark before the .let, you have exactly that object variable within your scope, okay? But you can do a safe call and then .let, and now all of a sudden in this let scope, in this block, because we've called .let safely, which will only happen if this is not null, well then this let scope knows the task is not null. So now we can do it.title, and we don't need the question mark. I'll go ahead and copy all of this, and I'll change my nullable task to it every time. It, and you can see how it's suggesting we don't need the question mark. If we didn't do a safe call with the let, then we would need the question mark. So whatever you call .let on, that is what you will have available to you within the let scope. So we'll do the question mark before .let, because this is the very common use case that people use this for when using scope functions. So we do a safe call, .let, and then we can remove all the question marks. We are guaranteed in this scope to have a non-null task. And with .let, by default, it will be called it, okay? And we'll talk about changing this in just a moment. So let's make a couple of notes. With a nullable object, my nullable task, we would always need to, 1, refer to the variable name each time, brackets could be long, and 2, do a safe call like this, okay? You'll see how my nullable task is a bit longer and a bit more clunky than just use a whatever is. So this, and then you'd maybe think, well, now I don't need the question marks, but actually, even though we've done the null check, we still need the question marks. If you hover over the warning, it says, smartcast to a non-null task is impossible. That just means it can't be certain that this nullable task is now not null. And the reason is the my nullable task variable is a mutable property that can have been changed by this time. And you're thinking, well, hang on, how can it have been changed? I'm checking if it's not null, and then I'm immediately accessing it, but this comes down to threading. There's no guarantee to the system that you're not accessing my nullable task on a different thread. So no, even though we've done the non-null check, we would still need to do the question marks, okay? Which is a bit clunky. But when you do my nullable task with a safe call and then .let, well, this scope is guaranteed to have a non-null task. So this is a very, very common use case. So we'll just mention this. The above let scope function is often used as an alternative to a basic if check. With the below check that the task is not null, we still need to do the safe call, exclamation mark. This is due to threading. My nullable task function, I touched upon it earlier. By default, it will be called it. So you will do it.title, it.id, it.description, okay? But actually, if I go back to the same my nullable task, and do question mark .let, well, we can actually name it. We can call it whatever we want. We can call it simply task. Maybe task is a bit more readable than it, so now I can do task.title equals my new title. Task.default name of the scope variable from it to anything we want. You type the new name just before the lambda for making your code. You might have a data class with nested number 1 task, a nullable task, var. So then you might make a favorite tasks object. You might say my faves equals my favorite tasks. And we'll just go ahead and put a couple of these in. So what can I do? I'll just do a couple of tasks with some favorite third task. The description can be null. Let's say, for example, this could be null. So we'll do my favorite tasks with a question mark, and we'll make it a variable. Okay, so the system is thinking my favorite tasks object, but it could be null. So if you wanted to access your number 2 task description, well, you'd have to do something like this. My faves question mark dot number 2 task. You would have to do the question mark because my faves could be null. And then to access the description, you'd have to do a safe call. you'd have to do a safe call for all of the properties by this point, because it could be null. So even for title, and that's because of this question mark. So we could be calling .title on something that is null. So you'd have a long, long chain of nullable safe calls. If you wanted to do multiple things with this title, for example, update it, my updated task to title, and then I want to also find out how long it is, okay, question mark dot length. Look at that, 3 question marks, okay? And then maybe I would do something else like my faves dot number 2 task dot title, and just, I'll change it again for some reason, okay? So all of that code, the repeated question marks, accessing the variable each time. But if I knew I wanted to do 2 or 3 things with number 2 task title, I could do something like this. My faves, safe call, number 2 task, safe call, and then .let. And now I have a non-null version of number 2 task, and I can get to work. Number 2 task it.title equals my new title. I could print the title length. No need for the safe calls, because I know that my number 2 task is not null inside this scope. And I've even got the solid introduction to our first scope, but we have the option scope function, and we've learned you can do it as a safe call to have a non-null version of the object, and that by default it is called it, but we have the option to call it anything that we want. And we've learned how it's a clean alternative to doing a null check and still having to use the safe calls. And we've also learned how it's preferable to accessing the same nested properties over and over again. You can find the property that you want, call let, do a safe call if you want, and then you've got a non-null version of that property inside the scope, and you end up typing just a lot less code. Okay, so that is the let scope function. In the next tutorial, we'll move straight onto the apply scope function, which is very similar. It can be used to achieve similar improvements to your code, but it works in a slightly different way. So let's do the apply function next.